4K video presents some serious challenges with the high bandwidth. Luckily, fiber is here to help. Why is 4K video so challenging? Well, 1080p was only 4 gigabits per second, but 4K video is 18 gigabits per second if you're using the full 60 frames per second 444 8-bit color. And it's even over 10 gigabits per second if you're just using HDR. The challenge with this is that 8K is also coming along, and that's going to be up to 48 gigabits per second. This has become a problem for copper cabling. 4K video with HDR is really the key to the real 4K experience. HDR is high dynamic range, and this improves the range of colors that the viewer has. It goes from about 16.8 million colors at 8-bit to over 1 billion colors with 10-bit. And anyone who's seen the difference between HDR and SDR definitely prefers HDR. It's just a much more amazing experience. The HDR standards that are used right now, HDR10, Dolby Vision, Hybrid Log Gamma, all require at least 10 bits of color. And this means that 4K video bandwidths are only going to continue to increase. So what is the actual bandwidth needed for 4K? Well, standard definition, which is 8-bit color, really only needed generally up to about 9 gigs, maybe 12 gigs if somebody was running 422. But these data rates were all that you needed for 8-bit. The problem was HDR came along, and HDR, as we said, needs 10-bit. So that means that the bandwidths are 11 gigs, maybe even 14 gigs, and the HDMI standard doesn't even actually support 4K 60 444 in 10-bit color because the bandwidth is somewhere around 22 gigabits per second, which is beyond the HDMI standard. So that means that your cabling can quickly become the limiting factor in your system design because many transmission solutions that are common today only have a 10 gig link. Fiber systems can do 18 gigs, so don't worry. So for example, all these data rates shown in red here can't be supported without compression for HD-Base-T, SDVoE, or video over IP if the system link is limited to 10 gigabits per second. The other challenge is that standard HDMI copper cables, pre-terminated in the factory, can only support 18 gigabits per second up to about 20 feet. And once you get up in that range, cable construction becomes a real key because not all cables are made the same. And if they aren't properly terminated and don't have nice clean solder joints, your signal integrity problems are going to be terrible for anything more than about 10 feet. Active copper cables are an option to increase the distance up to maybe around 50 feet, but those cables are thick and bulky and also can't be terminated in the field. Here at INEOS, we like to call that the 4K versus 4K problem. What is the system designer to do if the data rate that you need is above 10 gigabits per second? Well, a lot of the components that are available make assumptions that customers won't really see the difference or won't actually care because they can't support anything over 10 gigs. So they do things that actually reduce the frame rate back down below that threshold so they can continue to use the same technology. So they may reduce the 60 frame per second frame rate back down to 30 or 24, which can cause some aliasing or blurring. They may reduce the color gamut from 444 or 422 down to 420, which gives you less color realism. Or they may just disable high dynamic range. HDR, we said, was one of the key driving factors to 4K video, but if you don't have the bandwidth to support it, maybe you just don't do it. So many solutions make promises, but they don't always deliver real 4K. The other 4K option that people use is compression, where they try to take 18 gigabits per second and stuff it into this 10 gig or even a 1 gig pipe. They use the term visually lossless compression, which is actually a lossy compression, but they're banking on the fact that most people won't be able to see the difference between the uncompressed, which is shown here on the left, and the compressed image, which is shown on the right. So make sure you understand what you're getting when you're looking at your technology solution. So fiber to the rescue. Fiber really is the future. Fiber can support data rates way, way, way above 18 gigabits per second. 100 gigabit per second installations in data centers are very common nowadays. It's really future-proof. 8K signals at 40 gigabits per second can use the same fiber if you use standard pluggable installed fiber. And another benefit is that fiber cables are actually immune to electromagnetic interference. So all those issues that you have with ground loops and crosstalk that you get with your category cabling are not going to happen with fiber. You can run multiple fibers right next to each other in the same bundle and not get any problems with crosstalk. So there are three primary types of solutions for video over fiber. The first is active optical cables. This is a fixed length cable where the electronics to convert from the HDMI input to the optical signal and then back is all built into that fixed end, and the cable is pulled just like you would a standard pre-terminated HDMI cable and plugged right in. The problem with this is that you can't repair those cables. You have to pull them through the wall with the ends on them, and they can be a little bit fragile. And if you pull it through the wall and break it, you have to pull the whole thing out and replace your expensive cable again. And don't put it in backwards, because most of them are directional. The second type is what we call the optical video extenders. And many of these are black box type solutions, and they also a lot of times support control options such as RS-232, IR, or Ethernet in addition to the video. They usually use a pluggable optical interface such as an SFP or SFP+. But the thing to keep in mind with these solutions is that while they may employ fiber, a standard SFP Plus only supports 10 gigabits per second. Therefore, unless you have two SFP Pluses for a total of 20 gigabits per second, your link still is going to have to employ compression or color space conversion or HDR to SDR conversion, some other option to get that data rate back down. So you may not be getting true 4K even though you're using fiber. The third option are video adapters. And this is what we do here at INEOS. We make a video adapter where you plug in a standard SC terminated multi-mode fiber, and that one fiber can support the full HDMI 18 gigabits per second uncompressed up to 1,000 meters. Plus, our video adapter product can also support IR control. Once 8K comes along, simply unplug those adapters, leave your fiber in the wall, and plug in the 8K adapters when they're available. If you have any questions about fiber or fiber solutions, you can get a hold of us at contact@ineos.com or check us out on the web, www.ineos.com. Thank you.